Hello everyone. Are you looking to learn about blockchain? In this tutorial, you can learn about blockchain and other cryptocurrencies. So, if you want to learn about the blockchain in this course is appropriate for you. Let's take a look at what we will learn from this course. We will learn about Bitcoin, Ethereum, P2P, and other cryptocurrencies, and many more. So, if you want to take yourself in the next level for learning blockchain, then you can join our course. During learning, if you face any problem, then I am always here to help you. So I am expecting you to have you in my next lesson. How blockchain will change the world. Number 1, decentralized finance or DeFi. Blockchain technology enables decentralized finance, which allows users to access financial services without the need for intermediaries like banks. This can make financial services more accessible and affordable, particularly for people who are underbanked or unbanked. Number 2, supply chain management. Blockchain technology can help improve supply chain transparency by allowing businesses to track products from their own origin to their final destination. This can help ensure that products are authentic, ethically sourced, and meet regulatory requirements. Number 3, voting systems. Blockchain technology can be used to create secure and transparent voting systems. This could help reduce voter fraud and increase voter participation. Number 4, digital identity. Blockchain technology can help create secure and portable digital identities, which can help people prove their identity without relying on centralized authorities like governments or financial institutions. Number 5, real estate. Blockchain technology can help make real estate transactions more efficient and transparent by eliminating the need for intermediaries like lawyers and title companies. Overall, blockchain technology has the potential to transform many industries by creating more efficient, secure, and transparent systems by storing and transferring information. Introduction to Bitcoin, blockchain, and cryptocurrencies. Bitcoin, blockchain, and cryptocurrencies are digital technologies that have revolutionized the way we conduct transactions and exchange value. Bitcoin is a decentralized digital currency that was introduced in 2009 by an unknown person or group under the pseudonym Satoshi Nakamoto. It is based on a peer-to-peer network that allows for secure and transparent transactions without the need for intermediaries, like banks or other financial institutions. Bitcoin transactions are verified by network nodes through cryptography and recorded on a public digital ledger called the blockchain. Blockchain is a distributed digital ledger technology that underpins the Bitcoin network. It is a decentralized database that records transactions in a secure and transparent manner. Blockchain is based on a peer-to-peer network where each node maintains a copy of a ledger, and each transaction is verified by a consensus mechanism involving multiple nodes. This ensures that the ledger is tamper-proof and transparent. Cryptocurrencies are digital assets that are secured by cryptography and traded on blockchain networks. Bitcoin is the first and most well-known cryptocurrency, but there are also now thousands of others including Ethereum, Litecoin, and Ripple. Cryptocurrencies are most of Cryptocurrencies are most often used as means of payment, investment, and speculation. The introduction of Bitcoin and blockchain technology has the potential to disrupt traditional financial systems and create new opportunities for businesses and individuals. However, there are also challenges and risks associated with these technologies, such as volatility, regulatory uncertainty, and security concerns. Why cryptocurrencies are the next logical step in monetary evolution? Number 1, Decentralization. Unlike traditional currencies, cryptocurrencies are decentralized, which means they are not controlled by a single entity or government. Instead, they are based on blockchain technology, which allows for a distributed ledger that can be accessed and verified by anyone on the network. This removes the need for intermediaries like banks and creates a more transparent and secure system. Number two, accessibility. Cryptocurrencies are accessible to anyone with an internet connection, regardless of their location or financial status. This means that people who may not have had access to traditional banking services now have the ability to participate in financial transactions. Number three, security. Cryptocurrencies are secured by cryptography, which makes them extremely difficult to counterfeit or double spend. This creates a more secure system than traditional currencies, which are vulnerable to fraud and theft. Number four, efficiency. Cryptocurrencies allow for fast and efficient transactions without the need for intermediaries. This can help to reduce transaction costs and processing times, making transactions more convenient for everyone involved. Number five, potential for innovation. Cryptocurrencies are a new and innovative technology that has the potential to revolutionize the financial industry. They are already being used for a variety of purposes, such as micropayments, remittances, and online purchases. And there is still much more potential for future applications. Overall, cryptocurrencies offer a more decentralized, accessible, secure, efficient, and innovative monetary system than traditional currencies, making them a logical step in the evolution of money. However, it is important to note that cryptocurrencies are still a relatively new and volatile technology, and there are still many challenges that need to be addressed before they can be widely adopted as a mainstream currency. How Bitcoin was born. Bitcoin was born in 2009 when an individual or group of individuals operating under the pseudonym Satoshi Nakamoto released a white paper titled Bitcoin, a peer to peer electronic cash system. The white paper proposed a decentralized digital currency that would operate without the need for a central authority like a bank or government. Instead, transactions would be verified and recorded on a public ledger called the blockchain, which would be maintained by a network of users running specialized software on their computers. To incentivize users to maintain the network and verify transactions, Bitcoin introduced a system of rewards for miners who solve complex mathematical problems to add new blocks to the blockchain. These rewards are paid out in newly minted Bitcoin. Bitcoin quickly gained popularity among early adopters who saw it as a way to conduct anonymous and decentralized transactions. Since its inception, it has grown in value and gained wider acceptance as a form of payment and store of value, through, though it remains controversial and subject to volatile price swings. The core of Bitcoin system is the blockchain, which is a public ledger of all transactions that have occurred on the network. This ledger is maintained by a decentralized network of computers, which are in which are incentivized to verify and record new transactions through the issuance of new bitcoins. In order to prevent fraud and ensure the integrity of the network, Bitcoin uses a process called proof of work. This involves solving complex mathematical puzzles in order to validate new transactions and add them to the blockchain. The first computer to solve the puzzle is rewarded with a new Bitcoin, which serves as an incentive for maintaining the network. One of the key features of Bitcoin is its limited supply. Only 21 million Bitcoins will ever be created, and this cap is designed to ensure the currency remains scarce and valuable over time. Despite its relative anonymity, and lack of centralized control, Bitcoin has gained a significant following in the years since its creation. It is now accepted as a form of payment by a growing number of businesses around the world, and many people see it as a potentially revolutionary new form of money. While Bitcoin's origins and creator remains shrouded in mystery, its impact on the world of finance and technology is clear. Whether it will ultimately fulfill its promise as a decentralized and revolutionary form of currency remains to be seen. But there is no doubt that it has already made a significant impact on the world of finance and technology. Major historic milestones preceding Bitcoin's creation. The creation of Bitcoin. The creation of the first digital currency. In 1983, American cryptographer David Chaum created the first digital currency called eCash. It was designed to provide anonymity to its users and prevent double spending. The invention of public key cryptography. In 1976, Whitefield Diffie and Martin Hellman invented public key cryptography, which made it possible for two parties to communicate securely without sharing a secret key. The development of hash functions. In the late 1970s, cryptographers began developing hash functions, which are used to create unique digital fingerprints of data. Hash functions are a critical component of Bitcoin's blockchain technology. The emergence of peer-to-peer file sharing networks. In the late 1990s and early 2000s, P2P networks like Napster, Kazaa, and BitTorrent became popular for sharing music, movies, and other files. These networks demonstrated the potential for decentralized networks to share information and resources. The financial crisis of 2008. The global financial crisis of 2008 was caused by a combination of factors, including subprime mortgage lending, a house market bubble, and risky financial derivatives. This crisis led to widespread distrust of banks and financial institutions and highlighted the need for a decentralized and secure financial system. Bitcoin was created in the aftermath of the crisis as a response to the issues. Understanding the idea behind Bitcoin. Bitcoin is a decentralized digital currency that was created in 2009 by an anonymous individual or group of individuals known under the pseudonym Satoshi Nakamoto. Unlike traditional fiat currencies such as the US dollar or the euro, Bitcoin is is- Bitcoin is not issued by a central authority or government. Instead, Bitcoin is based on a decentralized system called the blockchain, which is essentially a public ledger of all Bitcoin transactions. The blockchain is maintained by a network of computers around the world, and each transaction on the blockchain is verified by multiple participants in the network to ensure its validity. One of the key features of Bitcoin is that it is designed to be deflationary currency, meaning that there is a finite supply of Bitcoins that can be created. The total supply of Bitcoins is capped at 21 million, which means that over time, the value of each Bitcoin should theoretically increase as demand for the currency grows. Bitcoin can also Bitcoin can be used to purchase goods and services, just like traditional fiat currencies. However, it has also become popular as a speculative investment, with many people buying and holding Bitcoins in the hopes that their value will continue to rise over time. While Bitcoin has faced some challenges and controversies over the years, it has also helped to pave the way for the development of other cryptocurrencies and blockchain based technologies. Today, Bitcoin remains one of the most well known and widely used cryptocurrencies in the world. How a coin is born and how blocks work. A coin, in the context of cryptocurrency, is born through the process called mining. Mining involves solving complex mathematical problems using specialized computer hardware. When a miner solves a problem, they are rewarded with a certain amount of cryptocurrency. Blocks, on the other hand, are building blocks of a blockchain. A block is essentially a digital ledger of transactions that is added to the blockchain by a miner. When a miner successfully solves a mathematical problem, they create a new block of transactions, which is then added to the blockchain. Each block contains a unique code called a hash, which is generated based on the data in the block. The hash serves as a unique identifier for the block and ensures that it cannot be altered without changing the hash. Once a block is added to the blockchain, it becomes a permanent part of the ledger, and its contents cannot be modified. This makes the blockchain an extremely secure and trustworthy system for recording transactions. The advantages of a decentralized payment system. A decentralized payment system has several advantages, including number one, security. In a decentralized payment system, the risks of hacking or fraud is greatly reduced as there is no central point of control that can be targeted by attackers. Number two, privacy. Decentralized payment systems allow users to maintain their privacy and anonymity, as transactions are conducted directly between users without the need of a central authority or monitor or regulate them. Number three, lower transaction fees. Decentralized payment systems typically have lower transaction fees than traditional payment systems, as they do not require intermediaries or third-party service providers to process transactions. Number four, accessibility. Decentralized payment systems are accessible to anyone with an internet connection, regardless of their location or financial status. This, this can be particularly beneficial for people in underbanked or developing countries who may who may not have access to traditional banking services. Number 5, transparency. Decentralized payment systems use blockchain technology, which allows for transparent and immutable records of all transactions. This enhances accountability and reduces the risk of fraud or corruption. Number 6, faster transactions. Decentralized payment systems can process transactions faster than traditional payment systems, as they do not require the same level of verification and approval from intermediaries. Overall, decentralized payment systems offer a range of benefits that make them an attractive alternative to traditional payment systems. Bitcoin's five forces. Threat of new entrants. The ease of entry into the cryptocurrency market creates a high threat of new entrants. However, the established network effect of Bitcoin and the increasing complexity of mining make it difficult for new cryptocurrencies to gain a foothold. Bargaining power of buyers. Bitcoin buyers have significant bargaining power as there are many alternatives to Bitcoin available in the market. Additionally, the market is highly transparent, and buyers have easy access to information about the currency. Bargaining power of suppliers. Bitcoin mining is controlled by a relatively small group of individuals and organizations, which gives them significant bargaining power. However, the decentralization of Bitcoin network limits their ability to control the currency. Threat of substitutes. Bitcoin faces competition from other cryptocurrencies such as Ethereum, Litecoin, and Bitcoin Cash, which could serve as substitutes. However, Bitcoin's established network effects brand recognition, and wide adoption make it difficult for substitutes to gain traction. Intensity of competitive rivalry. The cryptocurrency market is highly competitive, with many players vying for market share. However, Bitcoin's early adoption and established network effect provide it with a significant advantage over competitors. Blockchain, a distributed ledger. Blockchain is a type of distributed ledger technology that allows for secure and transparent recording of transactions. Essentially, a blockchain is a digital ledger that is maintained by a network of computers. Rather than a single centralized authority, each block in the chain contains a record of transactions, and once a block is added to the chain, it cannot be altered or deleted. The decentralized nature of blockchain makes it difficult for any one party to tamper with the data or manipulate the system. This makes it an this makes it an attractive technology for a wide range of applications, including financial transactions, supply chain management, and even voting systems. One of the most well-known uses of blockchain is the cryptocurrency Bitcoin, which uses a blockchain to record all transactions on its network. However, there are many other potential applications for blockchain technology beyond just cryptocurrency. As the technology continues to evolve, it is likely that we will see even more innovative uses for blockchain emerge in the years to come. Cryptography, the technique used to secure Bitcoin. Cryptography is a technique used to secure Bitcoin transactions and protect the privacy of Bitcoin users. It involves using mathematical algorithms to encode sensitive information, such as private keys and transaction data, so that it can only be accessed by those with the correct decryption key. In Bitcoin, cryptography is used in several ways. Firstly, public key cryptography is used to create a unique public address for each user. This allows users to receive Bitcoin from others without needing to reveal their private key. Secondly, private key cryptography is used to sign transactions and prove ownership of Bitcoin. Finally, cryptographic hashing is used to create a unique digital fingerprint for each transaction, which can be used to verify its authenticity. which can be used to verify its authenticity. The cryptographic techniques used in Bitcoin are considered to be very secure, making it difficult for hackers to steal Bitcoin or manipulate the blockchain. However, it is important for Bitcoin users to keep their private keys safe and secure, as losing them can result in the loss of their Bitcoin. Consensus mechanism, digital signatures. A consensus mechanism is a crucial part of blockchain technology that enables participants to agree on the state of the distributed ledger. It is a protocol that governs how nodes in a blockchain network reach agreement on the current state of ledger. Digital signatures are a cryptographic mechanism that plays a critical role in ensuring the the authentic, the authenticity, integrity, and non-repudiation non-repudiation of data in a blockchain network. There are a mathematical scheme. They are a mathematical scheme used to verify authenticity of digital documents or messages. Digital signatures work by using public key cryptography, where a sender signs a message using their private key, and the receiver verifies the signature using the sender's public key. This process ensures that the message was sent by the claimed sender and that it has not been altered during transmission. In a blockchain network, digital signatures are used to sign transactions and ensure their authenticity. Each node in the network can verify the digital signature of a transaction to ensure that it has been signed by the rightful owner and associated private key. This helps to prevent fraud, double spending, and other forms of malicious activity on the network. Overall, digital signatures are a crucial part of the consensus mechanism in a blockchain network, as they help to ensure that all nodes in the network agree on the authenticity and integrity of the data of the ledger. Consensus mechanism, mining and proof of work. Consensus mechanism is a way for a blockchain network to achieve agreement on the validity of a transaction or block. Mining and proof of work are two popular consensus mechanisms used by many blockchain networks, including Bitcoin and Ethereum. Mining is the process of adding new transactions to the blockchain by solving complex mathematical problems. Miners use powerful computers to compete with each other to solve these problems. And the first miner to solve the problem and add the new block to the chain is rewarded with newly minted coins and transaction fees. Proof of work is the underlying algorithm that governs the mining process. It requires miners to expend computational power in order to validate transactions and add them to the blockchain. The idea behind proof of work is that the cost of the computational power required to mine a block serves as form of economic disincentive against fraudulent behavior or attacks on the network. This makes it difficult for any single miner or group of miners to manipulate the blockchain. While proof of work is a secure and reliable consensus mechanism, it has some drawbacks. One of the main criticisms is that it requires a lot of computational power and energy consumption, which can be environmentally unfriendly and expensive. As a result, many blockchain networks are exploring alternative consensus mechanisms, such as proof of stake, which aim to achieve the same level of security with less energy consumption. Consensus mechanism, game theory. Consensus mechanism is a process by which a distributed network of nodes or participants reach an agreement on the state of the network. Game theory is a mathematical framework used to analyze decision making in strategic situations. In the context of consensus mechanisms, game theory can be useful to model the behavior of participants and the incentives, analyze the incentives that drive them to act in certain ways. In a blockchain network, for example, the consensus mechanism is the process by which nodes agree on the order and validity of transactions. Game theory can help to analyze the incentives that drive nodes to validate transactions honestly, even when they even when there may be incentives to cheat or manipulate the network. One commonly used consensus mechanism is blockchain networks is proof of work. In a proof of work system, nodes compete to solve complex mathematical puzzles, with the first node to solve the puzzle being rewarded with the right to validate a block of transactions. Game theory can be used to analyze the incentives that drives nodes to participate in this process and to determine how the difficulty of the puzzles should be set to maintain the security and integrity of the network. Other consensus mechanisms, such as proof of stake and delegated proof of stake, also rely on game theory to ensure the security and integrity of the networks. By analyzing the incentives that drive nodes to participate in these systems, game theory can help to design consensus mechanisms that are secure, efficient, and resistant to attack. Consensus mechanism. What happens if miners misbehave? In a blockchain system that uses a consensus mechanism like proof of work, proof of stake, or another type of consensus algorithm, miners are responsible for verifying transactions and adding new blocks to the blockchain. However, if miners bis- if miners misbehave, it can lead to security and reliability issues in the network. In proof of work, if miners misbehave by attempting to add invalid transactions or manipulate the blockchain in some other way, the rest of the network will reject their blocks, and they will not receive any rewards. This is because other nodes on the network will not recognize their blocks as valid and will not add them to their copy of the blockchain. These misbehaving miners will also lose any resources they have invested in the mining process, such as electricity and computational power. In proof of stake, the consensus for misbehaving miners are similar. If a validator misbehaves by attempting to add invalid transactions or manipulate the blockchain, they will lose their stake and may be banned from participating in the network. In both proof of work and proof of stake, the consensus mechanism is designed to incentivize miners or validators to act honestly and follow the rules of the network. This helps to ensure the security and reliability of the blockchain system. Consensus mechanism. An important detail about consensus attacks. Consensus mechanism is a critical component of blockchain technology, which ensures that all participants in a decentralized network agree on the state of the ledger. Consensus attacks are attempts to disrupt the consensus mechanism of a blockchain network, allowing malicious actors to manipulate the state of the ledger and potentially steal assets or execute other malicious activities. One important detail about consensus attacks is that they can take various forms depending on the consensus algorithm used by the blockchain network. For example, in a proof of work consensus algorithm, consensus attacks can take the form of a 51% attack, in which an attacker gains control of the majority of the computing power on the network and can rewrite the blockchain's history. In contrast, in a proof of stake consensus algorithm, consensus attacks can take the form of a long range attack or a nothing at stake attack. In a long range attack, an attacker could manipulate the blockchain's history by gaining control of a significant amount of cryptocurrency used in the proof of stake consensus mechanism, even if the attacker did not have control of of the current block generation process. A nothing at stake attack occurs when a malicious actor attempts to attempts to create two or more forks of the blockchain and double spend coins on each fork, as there is no penalty for doing so in a proof of stake system. In summary, consensus attacks can take different forms depending depending on the consensus algorithm used by the blockchain network. Understanding the understanding the vulnerabilities of a particular consensus mechanism is essential in developing countermeasures against consensus attacks. Peer-to-peer networks or P2P networks. A P2P network is a type of network where all devices or nodes on the network have equal status and are able to communicate with each other directly without the need for a central server or authority. In a P2P network, each node acts as both a client and a server and can share resources, such as files or processing power, with other nodes on the network. Peer-to-peer networks are often used for file sharing, such as in the case of BitTorrent, where users share files with each other directly rather than downloading them from a central server. Peer-to-peer networks can also be used for other applications, such as communication, where, where users can chat or make calls with each other directly without the need of a central server. One of the main advantages of peer-to-peer networks is their scalability and resilience, as they can continue to function even if some nodes fail or leave the network. However, peer-to-peer networks can also be more difficult to manage and secure, as there is no central authority to oversee the network and ensure its security. One of the key advantages of P2P networks is their scalability and resilience, as they can continue to function even if some nodes fail or leave the network. This is because each node is able to communicate directly with other nodes, allowing the network to reconfigure itself and continue operating. Additionally, P2P networks are often more efficient than traditional client-server networks, as they allow resources to be shared among nodes, reducing the need for central servers and increasing the speed of data transfer. However, P2P networks can also be more difficult to manage and secure than traditional client-server networks, as there is no central authority to oversee the network and ensure its security. This can lead to issues such as data privacy violations, malware infections, and other security risks. Additionally, P2P networks can be vulnerable to attacks such as distributed denial of service or DDoS attacks, where attackers flood the network with traffic and overwhelm it. To address these security concerns, various approaches have been developed to secure P2P networks, such as using encryption and digital signatures to secure data transmission, and implementing reputation systems to help identify and exclude malicious nodes. Additionally, some P2P networks use hybrid architectures that combine P2P and client server models, providing the benefits of both while minimizing the drawbacks. In summary, P2P networks are a type of network where all devices or nodes on the network have equal status and communicate with each other directly. They are often used for file sharing and communication, and offer advantages such as scalability and resilience. However, P2P networks can also be difficult to manage and secure, and various approaches have been developed to address these challenges. P2P networks offer several advantages over traditional client-server networks. Some of the key advantages of P2P networks include scalability. P2P networks can be more scalable than traditional client-server networks, as they allow resources to be shared among nodes, reducing the need for central servers and increasing the speed of data transfer. This makes P2P networks particularly useful for applications such as file sharing and large amounts of data need to be transferred quickly and efficiently. Resilience. P2P networks are often more resilient than traditional client-server networks, as they can continue to function even if some nodes fail or leave the network. This is because each node is able to communicate directly with other nodes, allowing the network to reconfigure itself and continue operating. Decentralization. P2P networks are decentralized, meaning that there is no single point of failure or control. This makes them this makes them more resistant to censorship and other forms of control, as there is no central authority that can be targeted or shut down. Cost, effi- Cost effectiveness. P2P networks can be more cost effective than traditional client server networks, as they do not require expensive server infrastructure or centralized storage systems. This can be particularly beneficial for small businesses or organizations with limited budgets. Efficient use of resources. P2P networks allow for the efficient use of resources as each node on the network can share resources such as bandwidth and processing power. This can help to reduce costs and improve performance. Overall, P2P networks offer several advantages over traditional client server networks, including scalability, resilience, decentralization, cost effectiveness, and efficient use of resources. However, P2P networks can also be more difficult to manage and secure than traditional networks, and various approaches have been developed to address these challenges. While P2P networks offer several advantages over traditional client server networks, there are also several disadvantages to consider. Some of the key disadvantages of P2P networks include security risks. P2P networks are often more difficult to secure than traditional client server networks, as there is no central authority to oversee the network and ensure its security. This can lead to issues such as data privacy violations, malware infections, and other security risks. Quality of service. P2P networks can be more difficult to manage than traditional client server networks, as there is no central authority to manage resources and ensure a consistent level of service. This can lead to issues such as slow data transfer rates and network congestion. Dependence on nodes. P2P networks are dependent on the availability and reliability of nodes on the network. If too many nodes fail or leave the network, it can become unstable or even collapse entirely. Legal concerns. P2P networks have been associated with infring- P2P networks have been associated with copyright infringement and other illegal activities, as they can be used for the unauthorized sharing of copyright content. Complexity. P2P networks can be more complex to set up and use than traditional client-server networks, as they require each node to communicate directly with other nodes on the network. This can be challenging for non-technical users and may require specialized software or configuration. Overall, while P2P networks offer several advantages over traditional client-server networks, they also have several disadvantages to consider, including security risks, quality of service issues, dependence on nodes, legal concerns, and complexity. To address these challenges, various approaches have been developed to secure P2P networks, manage resources, and ensure a consistent level of service. A software code base refers to the collection of source code files that make up a software program. It includes all the code files, libraries, dependencies, and other resources required to build and run the software application. The code base typically contains the core logic of the software program, as well as configuration files, documentation, and tests. It is often managed using vision control software such as Git or SVN, which allows developers to collaborate on the code, track changes over time, and manage different versions of the software. A well-organized and well-documented code is based A well-organized and well-documented code base is essential for maintaining and evolving software applications over time. It can also improve the efficiency and effectiveness of development teams by enabling them to easily navigate and understand the code, identify bugs and issues, and implement new features or updates. There are several key components of a software code base, including the programming language used to write the code, and libraries and frameworks used to build the application, and the development environment used by the development team. The, progra- the programming language used for the code base can have a significant impact on the readability, maintain- maintainability, and scalability of the software application. It is important to choose a language that is well suited to the project's requirements and that the development team is familiar with. Libraries and frameworks are collections of pre-written code that can be used to simplify the development process, reduce development time, and improve code quality. They can also provide access to additional features and functionality that would be difficult to implement from scratch. The development environment used by the development team includes tools such as integrated development environments, IDEs, code editors, debuggers, and build automation tools. These tools can help streamline the development process and make it easier to manage the code base. Finally, it is important to have good documentation and tests in place to help ensure that the code base is well documented, well tested, and easily understood. This can help reduce bugs, improve code quality, and make it easier for developers to maintain and evolve the software application over time. In summary, a software code base is a crucial component of any software application, and it is important to ensure that it is well organized, well documented, and well tested. This can help improve code quality, reduce bugs, and make it easier for developers to maintain and evolve the software application over time. Software code base, the script programming language. Script is a high-level programming language that is often used for web development and server-side scripting. It is a dynamically typed language, which means that data types are not explicitly declared and can change during runtime. Some features of script include easy to learn. Script is relatively easy to learn and understand, especially for those who are new to programming. Its syntax is simple and intuitive, making it a good choice for beginners. Cross-platform. Script can be run on multiple platforms, including Windows, Linux, and Mac OS. Dynamic typing. As mentioned earlier, script uses dynamic typing, which allows for flexibility and easier coding. However, this also means that errors may not be caught until runtime. Object-oriented. Script is an object-oriented language, which means that it uses object to represent data and functionality. This makes it easier to organize and maintain code. Interpreted. Script is an interpreted language, which means that the code is executed directly without being compiled first. This can result in slower execution times compared to compiled languages, but it also makes it easier to write and test code. Overall, script is a versatile language that is used in a variety of applications, including web development, server-side scripting, and automation. Its, its simplicity and flexibility make it a good choice for beginners, while its object-oriented features make it a powerful tool for more experienced programmers. Alternative use cases of Bitcoin. Bitcoin has been traditionally used as a digital currency for making transactions and storing value. However, there are several alternative use cases of Bitcoin beyond its traditional use as a digital currency. Number one, digital gold. Bitcoin can be used as a store of value, similar to gold. This is because Bitcoin has a limited supply, making it a deflationary asset. It is not subject to it is not subject to inflationary pressures like fiat currencies. Number 2, remittances. Bitcoin can be used to send remittances across borders quickly and at lower costs compared to traditional remittance services. Number 3, micropayments. Bitcoin can be used for micropayments, which are small transactions that are typically less than a few dollars. This is because Bitcoin can be divided into smaller units, allowing for transactions that are smaller than a cent. Number 4, crowdfunding. Bitcoin can be used for crowdfunding campaigns, where individuals can raise funds for various projects by accepting Bitcoin donations. Number 5, smart contracts. Bitcoin can be used as a platform for creating and executing smart contracts. Smart contracts are self-executing contracts with the same terms of the agreement between buyer and seller being directly written into lines of code. Number 6, decentralized applications or DApps. Bitcoin can be used as a platform for building decentralized applications. These are applications that run on a blockchain and are not controlled by a single entity. Number 7, trading. Bitcoin can be used for trading purposes, either as a standalone asset or as a trading pair with other cryptocurrencies or fiat currencies. Number 8, digital identity. Bitcoin can be used to create digital identities that are secure and cannot be tampered with, making it useful for identity verification and authentication purposes. These are just a few of the alternative use cases of Bitcoin. As the technology and adoption of Bitcoin continue to evolve, new use cases are likely to emerge. Bitcoin final remarks. Bitcoin is a decentralized digital currency that was created in 2009 by an unknown person or group of people using the name Satoshi Nakamoto. It is a peer-to-peer system that allows for the transfer of funds without the need for a central authority, such as a bank or government. Over the years, Bitcoin has gained popularity as a form of investment, as well as a means of payment for goods and services. It has also attracted criticism due to its volatility, lack of regulation, and association with illicit activities. Despite these criticisms, Bitcoin continues to have a significant impact on the financial world and has even led to the development of other cryptocurrencies. Its underlying technology, blockchain, has also shown promise in various industries beyond finance, such as supply chain management and voting systems. As with any investment, it is important to do your research and consider the potential risks before investing in Bitcoin or any other cryptocurrency. However, for those willing to take on the risks, Bitcoin can offer a unique investment opportunity and a way to participate in the evolution of financial technology. Introduction to Ethereum. Ethereum is a decentralized blockchain platform that enables developers to build and deploy decentralized applications or DApps and smart contracts. It was created by Vitalik Buterin in 2014 and launched in 2015. Like Bitcoin, Ethereum uses a proof of work consensus algorithm to validate transactions and create new blocks. However, it has plans to transition to a proof of stake consensus algorithm in the future, which will reduce energy consumption and increase transaction speed. Ethereum has its own cryptocurrency called Ether or ETH, in which is used to pay for transaction fees and computational services on the network. Ether can also be traded on various cryptocurrency exchanges. The key feature of Ethereum is its ability to run smart contracts, which are self-executing contracts with the terms of agreement between buyer and seller being directly written into lines of code. These smart contracts can be used to automate complex financial transactions as well as for creating decentralized applications such as decentralized exchanges, prediction markets, and voting systems. Ethereum has a large and active developer community with many decentralized applications and projects being built on top of the Ethereum blockchain. The Ethereum Virtual Machine. The Ethereum Virtual Machine, or EVM, is the runtime environment for smart contracts in the Ethereum network. It is a sandboxed environment that enables developers to write and deploy decentralized applications, or DApps, on the Ethereum blockchain. The EVM is responsible for executing smart contract code in a secure and deterministic manner. It ensures that all nodes in the Ethereum network run the same code and produce the same output. This allows for trustless execution of code, meaning that users can interact with smart contracts without the need for intermediaries. The EVM operates on a stack-based architecture and executes bytecode, which is a low-level representation of smart contract code. Smart contracts are typically written in high-level programming languages such as Solidity, which are then compiled into bytecode that can be executed by the EVM. Ethereum, a global platform for decentralized applications. Ethereum is a decentralized blockchain platform that enables the creation and execution of decentralized applications. Ethereum was created by Vitalik Buterin in 2014 and it went live in 2015. One of the main features of Ethereum is the ability to create smart contracts, which are self-executing contracts that can be programmed to automatically trigger certain actions when specific conditions are met. Smart contracts can be used to create a wide range of decentralized applications, including decentralized finance or DeFi protocols, non-fungible tokens, NFTs, marketplace, decentralized autonomous organizations, and more. Ethereum uses a native cryptocurrency called Ether, or ETH for short, as a means of value of exchange and to incentivize miners to secure the network. Ethereum's consensus mechanism is called proof of stake, which is more energy efficient than proof of work consensus mechanism used by Bitcoin. The Ethereum ecosystem is supported by a large and active community of developers and enthusiasts to create and maintain a wide range of tools and resources for developers to build on the platform. Ethereum is also highly programmable, with support for a wide range of programming languages, making it accessible to developers with different skill levels and backgrounds. Overall, Ethereum has emerged as a leading platform for decentralized applications, enabling a new generation of blockchain-based applications that are more transparent, secure, and accessible than traditional centralized applications. Ethereum and initial coin offering. Ethereum is a decentralized, open-source blockchain platform that allows developers to create decentralized applications, or DApps, and smart contracts. Smart contracts are self-executing contracts that automatically enforce the rules and regulations set forth by the parties involved. One popular use case of Ethereum is initial coin offering, or ICOs. An ICO is a fundraising method where companies create and sell their own cryptocurrency tokens to raise capital. These tokens are usually created and stored on the Ethereum blockchain, and investors can purchase them using Ethereum or other cryptocurrencies. ICOs became popular in 2017 and early 2018, with many startups and companies raising millions of dollars through this method. However, ICOs have also been criticized for being a potential breeding ground for scams and fraudulent activities, as the lack of regulation in the space has made it easy for bad actors to take advantage of the unsuspecting investors. In response to these concerns, many countries have started to regulate ICOs and cryptocurrency more broadly. In the United States, for example, the Securities and Exchange Commissions has taken action against numerous ICOs for violating securities laws. In addition, many reputable companies have started to use alternative fundraising methods, such as security token offerings, which are similar to ICOs and are subject to more stringent regulatory requirements. Decentralized autonomous organizations. A look into the future. Decentralized autonomous organizations, or DAOs, are a type of organization that operates through smart contracts and blockchain technology. Without the need for a central authority or intermediary, DAOs have the potential to revolutionize the way organizations operate, and their impact on the future cannot be overstated. One potential application of DAOs is in the governance of decentralized networks. For example, a DAO could be created to manage the development and maintenance of a blockchain network, with decisions made through a decentralized voting process. This could lead to a more democratic and transparent system of governance, with stakeholders having a direct say in the direction of the network. Another area where DAOs could have a significant impact is in the world of finance. A DAO could be created to manage a decentralized investment fund, with investors holding tokens that represents their stake in the fund. The DAO could then use smart contracts to automatically execute trades and manage the portfolio, with profits distributed to investors based on their token holdings. DAOs could also be used to create decentralized marketplaces where buyers and sellers can transact directly without the need for a central authority. This could lead to more efficient and transparent markets with reduced fees and increased competition. Overall, the future of DAOs is exciting and full of potential. As blockchain technology continues to mature, we are likely to see more and more organizations adopt this decentralized model, leading to a more democratized and decentralized world. However, there are also challenges and risks associated with DAOs, such as the potential for hacking and the need for effective governance mechanisms. As such, it will be more important for organizations and regulators to work together to ensure that DAOs are deployed in a safe and responsible manner. Here are some key takeaways about Ethereum. Number one, Ethereum is a decentralized blockchain platform that allows developers to build and deploy decentralized applications on top of it. Number two, Ether or ETH is the native cryptocurrency for of the Ethereum network and is used to pay for transaction fees and as a store of value. Number three, Ethereum is designed to be more flexible and programmable than Bitcoin, allowing developers to create smart contracts and execute complex transactions on the blockchain. Number four, smart contracts are self-executing contracts that run on the Ethereum blockchain, enabling decentralized applications to perform functions such as transferring funds, exchanging assets, and executing complex financial transactions. Number 5. Ethereum is in the process Ethereum is in the process of transitioning from a proof of work consensus mechanism to a proof of stake mechanism, which will make it more environmentally friendly and scalable. Ethereum has a vibrant ecosystem of developers, entrepreneurs, and investors who are working to build a decentralized future powered by blockchain technology. Number 7. Ethereum has faced challenges such as scalability, high gas fees, and security vulnerabilities, but the development community is actively working on solutions to overcome these obstacles. Overall, Ethereum is a powerful blockchain platform with a wide range of use cases and a growing ecosystem of developers and investors. Crypto exchange. A crypto exchange is a digital marketplace where users can buy, sell, and trade various cryptocurrencies such as Bitcoin, Ethereum, and Litecoin. Crypto exchanges act as intermediaries between buyers and sellers, providing a platform for users to exchange cryptocurrency for other cryptocurrencies or fiat currencies such as the US dollar, euro, or yen. Crypto exchanges can be centralized or decentralized. Centralized exchanges are operated by a company or organization and require users to deposit funds into their accounts before trading. Decentralized exchanges, on the other hand, operate on a distributed network and allows users to trade without depositing funds into an exchange account. Some popular crypto exchanges include Binance, Coinbase, Kraken, and Bitfinex. When choosing a crypto exchange, it is important to consider factors such as security, fees, and supported cryptocurrencies. It is also recommended to research the exchange's reputation and user reviews to ensure a reliable and trustworthy trading experience. Exchanges can be centralized or decentralized. Centralized exchanges are owned and operated by a single entity, while decentralized exchanges operate on a distributed network, meaning they are not controlled by a single entity. Centralized exchanges often offer more features and have higher trading volumes, while decentralized exchanges prioritize user privacy and security. To use a cryptocurrency exchange, users typically need to create an account and complete a verification process that may involve submitting identification documents. Once their account is approved, users can deposit funds into their account through bank transfers, credit cards, and other payment methods. Trading on an exchange involves placing buy and sell orders for a specific cryptocurrency at a certain price point. When a buy order matches a sell order, a transaction is executed and the digital currency is exchanged between the two parties. Exchanges typically charge fees for trading and may also charge withdrawal fees when users want to transfer their digital assets to an external wallet. Security is a significant concern for cryptocurrency exchanges, given the high value of the digital currencies they hold. Exchanges often employ a range of security measures, including two-factor authentication, cold storage, and encryption, to protect user funds from theft or hacking. In conclusion, a cryptocurrency exchange is a crucial platform for anyone interested in investing or trading cryptocurrencies. These exchanges allow users to buy, sell, and trade a range of digital currencies, providing access to a wide range of investment opportunities. While security remains a concern, advances in technology and security measures are making cryptocurrency exchanges increasingly safe and accessible. There are several advantages of using a cryptocurrency exchange, including high liquidity. Cryptocurrency exchanges provide high liquidity or digital assets, which means that users can quickly and easily buy and sell cryptocurrencies at market prices. Global access. Cryptocurrency exchanges allow users from all over the world to trade and invest in digital assets without any geographical barriers. Transparency. Transactions on a cryptocurrency exchange are transparent and recorded on a public ledger, which means that users can verify their transactions and ensure the integrity of the exchange. Low transaction fees. Cryptocurrency exchanges generally charge low transaction fees, which is significantly lower than traditional financial institutions. Wide range of cryptocurrencies. Cryptocurrency exchanges offer a wide range of digital assets for trading, providing users with access to a diverse portfolio for cryptocurrencies. Trading tools. Cryptocurrency exchanges offer a variety of trading tools, including charting tools, price alerts, and technical analysis tools, to help users make informed trading decisions. Security. Cryptocurrency exchanges have a strong focus on security, employing advanced security measures such as two-factor authentication, encryption and cold storage and protect user funds. Anonymity. Some cryptocurrency exchanges offer users anonymity, allowing them to trade without revealing their identity. Overall, cryptocurrency exchanges provide a fast, secure, and convenient way of users to buy and sell and trade digital assets, offering many advantages over traditional financial institutions. What is DAO or DAO? DAO or DAO stands for Decentralized Autonomous Organization. A DAO is a type of organization that is run by a set of rules encoded as computer programs called smart contracts, rather than being controlled by a central authority or group of people. In a DAO, decision-making power is distributed among its members, who can propose and vote on changes to the organization's rules and operations. This allows for a more democratic and decentralized decision-making process than traditional organizations. DAOs are often associated with blockchain technology and cryptocurrencies, as they rely on the blockchain to maintain transparency and security, and to facilitate transactions between members. Some popular examples of DAOs include MakerDAO, Uniswap, and Compound. DAOs have the potential to revolutionize the way organizations are run by enabling more democratic and transparent decision-making process. However, they are still relatively new and there are some challenges to be addressed, such as how to ensure accountability and prevent malicious actors from exploiting the system. Advantages of investing in Bitcoin. Number one, potential for high returns. Bitcoin is a highly volatile asset, and while this volatility can be risky, it also means that there is potential for significant returns. In the past, Bitcoin has experienced rapid price increases, and some investors have made significant profits. Number two, decentralized and secure. Bitcoin operates on a decentralized network, which means that it is not controlled by any government or financial institution. Transactions are secured through cryptography and are recorded on a public ledger, which makes it difficult for fraudulent transactions to occur. Number three, lower transaction fees. Compared to traditional financial transactions, Bitcoin transactions can be completed with lower fees. This is because Bitcoin transactions do not require intermediaries, such as banks or credit card companies. Diversification. Investing in Bitcoin can offer diversification benefits to an investment portfolio. This is because Bitcoin's price movements are not necessarily correlated with traditional asset classes such as stocks and bonds. Number five, accessibility. Bitcoin is accessible to anyone with an internet connection and a digital wallet. This makes it particularly appealing investment for people who may not have access to traditional financial services. However, it is important to note that investing in Bitcoin also comes with risks, including high volatility, regulator, 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 regulatory uncertainty, and the potential for fraud and hacking. It is important to do your research and understand the risks before investing in Bitcoin or any other cryptocurrency. While investing in Bitcoin has some potential advantages, there are also several disadvantages and risks that investors should be aware of. High volatility. Bitcoin is a highly volatile asset, and its price can fluctuate rapidly and unpredictably. This can create significant risks for investors who may be subject to sudden price movements. Lack of regulation. Bitcoin is not regulated by any government or financial institution, which means that there is no safety net for investors in the event of fraud or hacking. This lack of regulation also makes it difficult to access the value and potential risks of Bitcoin. Security risks. Bitcoin transactions are secured through cryptography, but this does not make them immune to hacking or fraud. In the past, there have been several high profile instances of Bitcoin exchanges being hacked and investors losing their funds. Limited acceptance. While Bitcoin has gained some acceptance from as a form of payment, it is not yet widely accepted by merchants or businesses. This can limit its usefulness as a currency and may make it more difficult to sell or exchange. Environmental concerns. The process of mining Bitcoin requires significant amount of electricity, which, which can have a negative impact on the environment. Some critics have argued that Bitcoin's environmental impact is unsustainable. Difficulty of use. For many people, Bitcoin and other cryptocurrencies can be difficult to use and understand. The process of setting up a digital wallet and making transactions can become complicated. And there is also a risk of human error or technical problems. Overall, investing in Bitcoin comes with significant risks and potential drawbacks. While there is a potential for high returns, investors should carefully consider these risks and only invest money that they can afford to lose. Additionally, investors should educate themselves on the technology behind Bitcoin and stay up to date on regulatory developments in the cryptocurrency space.
Hello, and welcome to our lesson on blockchain in the financial sector. Blockchain is a decentralized digital ledger technology that has the potential to revolutionize the way we do business. In the financial sector, one way that it will be impacted is it has the potential to transform a wide range of processes and practices. Today, we're going to look at a few of those use cases. The ones that we'll go through in depth are payment processing, identity verification, asset tracking, smart contracts, trade finance, and regulatory reporting. In our first use case of payment processing, one way that blockchain is being used in the financial sector is if we look at traditional payment systems, they rely on central authorities or intermediaries to facilitate the transfer of funds. But with blockchain, these transactions can be processed securely and quickly without the need for a central authority. This has the potential to reduce transaction costs and increase efficiency in the financial system. Another area where blockchain is being used is identity verification. Blockchain-based systems can be used to verify the identity of individuals or entities in a secure and decentralized manner. This could be used to improve the efficiency of identity verification processes throughout the financial sector. Asset tracking can be used in blockchain in things like supply chain management. We can track ownership and movement of assets, digital assets as well, such as stocks, bonds, and other financial instruments. This could improve transparency and reduce the risk of fraud in the financial markets. Smart contracts are another important application in blockchain, especially in the financial sector. These are self-executing contracts with the terms of agreement between the buyer and seller being directly written into lines of code. With blockchain, these contracts can be automated, reducing the need for manual processes and improve efficiency. Trade finance is another area where blockchain is being applied. The process of trade finance includes the reassurance or insurance of tracking letters of credit and other documents that can be streamlined using blockchain. This would reduce cost, time, and associated with international trades. Finally, blockchain-based systems could be used to automate the reporting of financial data to regulatory authorities, improving the accuracy, timeliness of reporting, and reducing the burden of financial institutions. So in summary, blockchain has the potential to transform the financial sector in a number of ways, including payment processing, identity verification, asset tracking, smart contracts, trade finance, and regulatory reporting. In all of these examples, the decentralized nature and ability to securely and transparently record and track transactions makes it a powerful tool moving forward in the financial industry. Thanks everyone for watching, and we'll see you in the next lesson. Hello and welcome. In this lesson, we will discuss the potential future applications of blockchain in a few different industries. Before we dive in, let's review what blockchain is. In short, blockchain is a digital ledger that is decentralized for records, transactions on multiple computers. This means that a single entity does not control it, and all the information on the blockchain is transparent and secure. So let's look at some examples. First being healthcare, real estate, predictive analysis, Internet of Things, also known as IoT, and the social impact. These are just a few examples of how blockchain could be used in the future. We will likely see the development of many more innovative and transformative blockchain applications as the technology continues to mature and evolve. Let's first talk about how blockchain could potentially be used in healthcare. One application is the storage and sharing of medical records. Currently, medical records are often stored in siloed systems that are not interoperable, meaning that they can be difficult for different healthcare providers to access and share patient information. Medical records could be stored in a secure, decentralized system that allows easy access and sharing by authorized healthcare providers. This could provide the quality and efficiency of patient care and reduce the risk of errors. Also, this can lead to inefficiency and potential harm situations, such as patients being prescribed allergy medication because their allergy was informed not readily available. With blockchain, that information could be shared between different institutions without concern of those inefficiencies. Another potential application of blockchain in healthcare is supply chain management. The pharmaceutical industry is particularly susceptible to counterfeiting, and it can be challenging to track the movement of drugs from manufacturer to patient. Using blockchain, we could create a transparent and secure supply chain that allows for traceability of drugs, helping to reduce the risk of counterfeiting and ensuring that the patients are receiving the authentic medications that they need. Finally, blockchain could also be used in the research and development of new drugs and treatments. By creating a decentralized platform for sharing and collaborating on research, blockchain could speed up development and process and make it more efficient. Things such as outbreaks and public studies, as well as vaccines, could be readily available through different information channels throughout the world. While there is still much work to be done to fully realize the potential of blockchain uses in the technology revolutions, specifically in healthcare, there are great improvements in security, efficiency, transparency, and other various processes. Blockchain could be used in real estate to facilitate automation of contracts, allowing for the automatic execution of terms when certain conditions are met. One potential application of this in the real estate industry is the creation of smart contracts. A smart contract is a self-executing contract with the terms of agreement between a buyer and a seller being directly written into lines of code. While blockchain could automate the buying and selling of real estate, allowing for efficient and secure transfer of ownership. Another application of blockchain in real estate is property records management. Currently, all property records are often stored in physical form and can be difficult to access and verify. Using blockchain would create a secure, decentralized system for storing and accessing property records, making verifying ownership easier and reducing the risk of fraud. In addition to these practical applications, blockchain could potentially be used to improve transparency and efficiency of the real estate industry. By creating a decentralized platform for engaging information, resources, and it would be possible to streamline various processes to reduce reliance on intermediaries. Next, blockchain could be used to create decentralized platforms for data sharing and analysis, allowing for development of more accurate predictive models. You could think of this as sharing AI. This could have a wide range of applications from supply chain management to healthcare, as we've previously seen. One potential application in the predictive analysis industry is creating decentralized applications and analysis platforms. The data is often siloed and challenging to access, which hinder the development of accurate predictive models. By using blockchain, it would be possible to create a secure, decentralized platform for the exchange and analysis of data, which would in turn make our predictive models more accurate. Another potential application is in the creation of decentralized prediction markets. A prediction market is a platform where individuals can buy and sell contracts based on the likelihood of a particular event happening. By using blockchain, it would be possible to create decentralized prediction markets that are transparent and secure, allowing for the most efficient and accurate prediction of future events. Now we're going to look at the Internet of Things, or IoT. So IoT and blockchain are two emerging technologies that have the potential to transform a wide range of industries and systems. First, let's define what IoT is. IoT refers to the network of physical devices, such as sensors, actuators, and other individual pieces of electronics that transmit data. That data can be connected to the internet and able to collect and transfer all the information to different services or devices. These devices are often embedded with other sensors that allow them to gather data about their environment. If you think of like a smart home, such as temperature and humidity. Blockchain could be used to securely connect and manage the data exchange between IoT devices, allowing for the creation of new and innovative applications and services. One of those applications would be combining IoT and blockchain in supply chain management. By attaching sensors to physical goods, it would be possible to track the movements of those goods throughout the supply chain in real time. This could help improve efficiency and transparency of the supply chain, as well as reduce the risk of fraud or potentially dangerous products that are counterfeited getting into the market. IoT and blockchain could also be used in the transportation industry by using sensors to gather information of the movement of the vehicles It would be possible to create a decentralized transportation system that would allow for the efficient and transparent exchange of information and resources. This could potentially help reduce traffic congestion and improve the overall efficiency of the transportation system. This one I found particularly interesting. Another application is around the energy industry using IoT. By using IoT devices to gather the data about energy usage and production, it would be possible to create a decentralized energy system that allows for peer-to-peer exchange of energy. You think about taking renewable energy and sharing it with your neighbor or potentially members of your community. This could help reduce reliance on traditional energy sources and increase the adoption of renewable energy. Let's talk about the social impact. Blockchain could be potentially used to create decentralized platforms for social impact projects, allowing for the efficient and transparent distribution of resources and tracking progress. In addition to these practical applications, blockchain could have a significant impact on various social and political systems. For example, the use of blockchain in voting systems could help improve security and transparency of elections, reducing the risk of voter fraud and increasing confidence in the electoral process. That could be done in public. It could also be done within the private sector if you think about a board or having a decentralized organization, as well as in government. And then, as we stated, reducing the risk of fraud in all of these processes. Looking into the future, it is clear that blockchain has the potential to revolutionize a wide range of industries and systems. However, there will be limitations. One of the biggest potential hurdles is to have the widespread adoption of blockchain is the issue of energy consumption. The decentralized nature of blockchain technology requires a large amount of energy to power the network, which has led to concerns about its sustainability. However, there are ongoing efforts to address this issue through using more energy efficient protocols and using renewable energy resources. Overall, the future of blockchain looks bright. While there are still many challenges to overcome, the potential benefits of this technology are vast and could significantly impact various industries and systems. As the technology continues to evolve, we will likely see increasing adoption and integration of blockchain into various different industries sectors. Thanks, and I'll see you in the next lesson. Hello, and welcome to our lesson on industrial application of blockchain technology. Blockchain is already being used in several industrial applications. Today, we're going to discuss some examples of how it's being used in this sector. So the use cases that we'll go over today are supply chain management, quality assurance, asset tracking, supply chain finance, and energy trading. In our first use case of supply chain management, blockchain is being used to track the movement of goods through the supply chain from the source to the final destination. This can help improve efficiency, reduce the risk of fraud, and increase transparency. For example, let's consider a company could use blockchain to track the movement of raw materials from its suppliers to its manufacturing facility, and then track the movement of finished goods from the factory to the distribution centers. And lastly, end up tracking it to the retailers. When it comes to quality assurance, blockchain can be used to verify the quality and authenticity of industrial products, such as pharmaceuticals, electronics, automotive parts. So let's look at an example. A company could use blockchain to create a tamper-proof record of testing and certification of the process and products, providing its customers with a high level of confidence in the quality and safety that they are purchasing. When it comes to asset tracking, blockchain can be used to track the movement of maintenance industrial assets, such as machinery and equipment. If we look at an example for asset tracking, a company could use blockchain to track the maintenance history of its equipment. For instance, any upgrades or specific things, maybe oil changes, etc. It includes the dates of service, the parts that were replaced, and the technicians who performed the work. This can help to improve the efficiency of maintenance operations and reduce the equipment failure. When it comes to supply chain finance, blockchain is being used to improve the efficiency and security of supply chain finance, which involves the financing of goods as they move through the supply chain. For example, a company could use blockchain to automate the process of invoicing and payment for goods and services, reducing fraud and reducing the time required to complete transactions. Energy trading. This one I find fairly unique. So blockchain is being used to create more efficient and transparent energy markets. For example, a company could be using blockchain to track the production and consumption of renewable energy, such as wind or solar, and facilitate the trading of any excess energy among users. So in summary, blockchain technology has the potential to greatly improve efficiency, transparency of the industrial processes, and we can expect to see more innovative use cases emerge as the technology continues to mature. Thanks for watching, and we'll see you in the next lesson. Hey, and welcome to this video on the Ethereum virtual machine, also known as EVM. The EVM runtime is the environment for smart contracts in Ethereum. It is a 256-bit register machine that is designed to execute the same code exactly as intended, making it a crucial component of Ethereum's consensus mechanism. The EVM is implemented as a stack-based virtual machine, which means that it executes code by pushing and popping values from the stack. It is built in a set of opcodes or operations that can be used to manipulate values on the stack to perform calculations, interact with the Ethereum blockchain. The EVM is designed to be deterministic, meaning that it will always produce the same output given the same input. This is important because it allows the Ethereum network to reach consensus on the state of the blockchain and ensure that all nodes are in the agreement. In the Ethereum virtual machine, gas is the unit of measurement that is used to calculate the cost of executing a smart contract or another transaction on the Ethereum blockchain. It is used as a way to ensure that users pay for the resources that they use on the network and to prevent spam and other malicious activity. Gas is used to pay for the computational resources required to execute a transaction or contract and is measured in units called gas units or simply gas. Gas is paid in Ether or ETH, the cryptocurrency that is used to power the Ethereum network. Transaction costs, on the other hand, are the fees that the user pays when they send transactions on the Ethereum network. These fees are paid in Ether, the native cryptocurrency, and are used to compensate miners for the resources they used to process and validate transactions. Transaction costs are calculated on the gas consumption of the transaction and the current gas price, which is the cost of gas in Ether. This gas price is set by users when they send a transaction and can be adjusted based on supply and demand. Users who are willing to pay higher gas will generally have their transactions processed more quickly, while users who are willing to pay lower gas prices may have to wait longer for their transactions to be processed. So we're going to look at a gas calculation example. Each action that is performed within a smart contract or transaction requires a certain amount of gas to execute. For example, the operations that perform a complex calculation or interact with other contracts may require more gas than a simple operation like an arithmetic calculations or data storage. For example, let's say you want to send a transaction that requires a gas price of 20 gwei and a gas limit of 200,000 gas units. To calculate the cost of this transaction in ETH, you would use the following equation. We're going to take the gas price in gwei times the gas limit, or the units in gas, or gas units. It equals the cost of ETH. So if we had 20 times 200,000, it would equal 0.004 ETH. So in summary, gas is the unit of measurement that is used to calculate the cost of executing smart contracts and transactions on the Ethereum network, while the transaction costs are the fees that the user pays in Ether to have their transactions processed. So let's talk about smart contracts. Smart contracts are self-executing contracts within the terms of the agreement between the buyer and the seller being directly written into lines of code. The code and the agreements contained are stored on the Ethereum blockchain and are replicated across the entire network. This ensures that the terms of the agreement are transparent and cannot be altered, making smart contracts a secure and reliable way to facilitate transactions. To write and deploy smart contracts, developers can use a high-level language like Solidity, which is then compiled down into EVM bytecode and deployed on the Ethereum blockchain. So we're going to look at a simple contract that is written in Solidity and will be compiled down to Ethereum or EVM bytecode. So right here at the beginning, you'll see the version of Solidity, and it means that anything 0.6, 0.12 or higher can run this contract. In this simple contract, we have two functions. Set, which allows a user to set the value of stored data, and get, which allows the user to retrieve the value of the stored data. To deploy this contract to the Ethereum blockchain, you'll need to use a tool like Remix, which is a browser-based Solidity compiler and runtime environment. You can also use the Solidity compiler and the Ethereum JSON RPC API to deploy the contract programmatically. We're also going to look at WebJS 3 versus ETHJS 3. So these are two different JavaScript libraries that provide an interface for interacting with the Ethereum blockchain. They also allow you to send transactions, access your smart contract data, and listen for different events on the Ethereum network. Reminder that both of these are just JavaScript files, so they can be used on front-end development with HTML and CSS to build what are called dApps. However, between the two libraries, there are some key differences. WebJS 3 is the official Ethereum JavaScript library maintained by the Ethereum Foundation. It is a comprehensive library that provides a wide range of functionality for interacting with the Ethereum blockchain. ETH.js is a lightweight alternative to WebJS. It's designed to be easier to use and more performant. It provides a simple promise-based API for interacting with the Ethereum blockchain, and it has a smaller footprint than WebJS. One of the main differences between the two libraries is that WebJS uses callbacks for handling asynchronous operations, while ETH.js uses promises. This means that if you prefer to use promises in your code, ETH.js may be a better choice for you. Overall, the choice between WebJS and ETH.js will depend on your specific needs and preferences. Both libraries are widely used and well documented, and they provide reliable and feature-rich interfaces for interacting with the Ethereum blockchain. So now we're going to look at an example of how you can use WebJS to send transactions to the Ethereum network. In this code, we're going to start by connecting to the Ethereum network using WebJS. So we're using our const, we're requiring the library itself, and then we're setting up an HTTP provider, specifically in this example to our local host. It then sets the address, which is here, and a private key. So think of the address for your wallet as well as the private key so that you can interact with your wallet. Next, it sets the details of the transaction. Who is this going to, the value in Wei, and the gas price in Wei. And then the gas limit, which is the maximum amount that you would want to spend. And a reminder, 1 ETH is equal to 1 times 10 power to the 18 Wei. Then it signs the transaction using the private key to send it to the Ethereum network. Finally, we get a receipt of the transaction, which we are going to print to the console. This is just one example of how you can use WebJS 3 to interact with the Ethereum blockchain. There are many more functionalities and methods available in the library, including functions to interact with smart contracts, listening events, and accessing the blockchain data. So now let's look at an example of ETH.js. Again, we're going to be importing the library at the top, and then we'll be creating a connection very similar to what we did through the HTTP provider, except we're just going to say new ETH. Then again, as we did with WebJS or Web3.js, we're going to set our address, set our private key, and then do the same steps of where are we sending this to, the value in Wei, the gas price in Wei, and then our gas limit that we're willing to spend. And just like in WebJS, we're going to, or Web3, we are going to sign our transaction with who it's to, the value, the gas price, the gas limit. We're going to make sure that it's signed with our private key. And then we're going to do an await and get our receipt back, and we'll do a console log on the receipt. Both Web3.js and ETH.js can be imported and used in frameworks like React. So we're going to go ahead and do a quick look at what a React example would be for both libraries. So in this Web3.js example, the component uses the useEffect and the useState hooks to handle the setup and state management for Web3.js. The component first checks if the browser has Web3 injected and enabled. If so, it creates a new instance of the Web3 object with the injected Web3 provider. It then calls enable method to get the user's permissions to access their accounts and sets their first account return to the state. Finally, it renders the component, with the account address. Just note that this is a very basic example, and it should show you how to handle errors and there are other edge cases when working with Web3 blockchain technology. But you can imagine using this type of a script in something like a front-end Web3 game. So now if we look at ETH, it's very similar. Again, we're still going to be using React as the library. So in this example, we're also using the useEffect and use state hooks to set up the state management for ethers, which is still just ETH.js. The component first checks if the browser has Web3 injection enabled and creates a new instance of the Web3 provider object. With the injected Web3 provider, it then calls the enable method to go get the user's permission, access their accounts, and sets the first address returned to the state. Finally, it renders the component with the account address. Again, note that this is a simple example. There are a lot of edge cases and error handling that we want to put into this kind of version or this kind of code. And this is the version of Ethers number 5.0. All right, in summary, the Ethereum virtual machine is a crucial component of the Ethereum blockchain. Reminder that it enables execution of smart contracts and ensuring the integrity of and security of the transactions. Thanks for watching, and we'll see you in the next lesson.